Hello, my name is Danny Lewin and I'm a professor in the Faculty of Chemical Engineering at the Technion, the Israel Institute of Technology. I've taught the capstone process design course here for almost 20 years and have continuously updated my teaching approach to make it as effective as possible. This year, making the most dramatic change to date, I flipped my class and feel like I have rediscovered the topic. In this short video, I will show you why.
What are we trying to achieve as teachers? Well, obviously, our objective would be to teach. In this case, process design to hopefully motivated and interested students. But I think we'll all agree that the real target would be to ensure that our students learn. Most design courses are taught using the lecture as the main vehicle to transmit information. Let's examine the effectiveness of this approach. First, in the lecture, say of 2 to 3 hours, the materials taught in that week are delivered at the lecturer's pace, which probably will not suit most students. If there is any participation in class discussion, it will involve 5 to 10% of the students present, and I'm being optimistic, with the rest of the students mostly passive. With such low class participation, the lecturer has no way of knowing who got it and how much learning is really going on in his classroom. This is followed by an exercise session of, say, 1 to 2 hours, where the students now hear another lecture, this time from the assistant, and again with perhaps 5 to 10% participation in Q&A, maybe the same 5 to 10% we saw active in the lecture. Once again, most of the students are passive observers in the learning process. We then send our students home to do homework, which might take them between 2 to 5 hours. This is the first time most of the students will take an active role in their learning, and now they're on their own. If we require them to hand in their work for grading, they will all do so, but not all of them will have done this on their own, and so this will provide an unreliable measure of the true capabilities of the students. Worse, even if all the homework is graded, the feedback will come weeks later, too late to be of much use to either the students or the lecturer. What are the features of the conventional approach? Well, for one thing, we're relying on the lecturer as the main, if not the only, mode of communication with students. Often this is the only contact time between students and the teaching staff, regrettably squandered on what is known to be an ineffective way of learning. Indeed, as stated so well by Edwin Emery Slosson of the University of Kansas, lecturing is that mysterious process by which the contents of the notebook of the professor are transferred through the instrument of the fountain pen to the notebook of the student without passing through the mind of either. What is the other feature of the conventional approach? Yep, passive students. And if they are passive, they will learn less. And when do we find that out? Right, in the final exam, when it's too late to fix the problem. Here is a typical distribution of final grades for my design course before I made the switch to active learning. It's a bimodal distribution which divides the class roughly into two populations, one that clearly got it and one that largely didn't, with a depressingly long tail stretching down to very low grades. What can be done to change this? Yep, you've guessed it, get your students active. One comprehensive solution that does work is to flip the classroom. Let me show you how that works. In the flipped classroom, the week of activity starts with the online lecture, which the students need to watch in advance of the week's activities. The week's lectures need to be pre-recorded as a series of 10 to 15-minute video segments, each followed by an online quiz question that the students answer. By monitoring the class responses to the quiz questions, the lecturer can assess class competence by lecture segment in advance and plan accordingly. This is followed by the class meeting, in which the lecturer revisits only portions of the lecture materials that were observed to cause the most grief to the students. This leaves most of the time to creatively explore the week's materials and to solve open-ended problems at exam level with the participation of the entire class. This is a much better use of class time than just lecturing, and it keeps most of the students engaged actively in their learning. The last activity of the week is the active tutorial, which incorporates active demonstrations of problem solving, often not needed since the students already saw that in the class meeting. The active tutorials is there to allow time for students to come to grips with problem sets on their own or working in teams. And of course this is helped by having seen our open-ended problem solving in the class meeting. And this is the most important of all the activities, as it's where most of the learning happens. Flipping means getting your students to take control of their learning. And they really do learn online. My biggest fear after having decided to go 100% flipped in the process design course was that the students would not cooperate and would not actually learn seriously online. The advantage of the Moodle site we set up is that it allows for detailed monitoring of class activity in each of the course segments. This plot shows the number of times video segments were accessed each day for the first half of the semester. Given that each week was divided into about 10 video segments, it's pretty clear that most of the students did in fact participate. They received credit not according to how well they scored on the quizzes, but by having spent enough time online to actually watch the movies. And indeed, on average, 87% of the class spent enough time to cover the materials acceptably and got credit for it. Several things happen in the 2-hour class meetings. The meetings begin by reviewing those sections of the online class that most of the students had problems with, as indicated by the poorer class performance of the associated quiz questions. There's ample time to answer students' questions. This year, the questions asked required a depth of understanding that exceeded anything I have experienced in all the years teaching design. Clearly, students were well prepared for class. Quiz questions were posed to test constructive knowledge using clickers, a personal class response system that enables collection of responses to the questions from all of the students at the meeting, presenting the distribution of answers as a histogram. This is very helpful to trigger class discussion. But most of the time was used to work with students on the solutions of typical exam-level open-ended problems. This video segment shows a few minutes of typical class activity in a class meeting. Of course, the video is recorded in Hebrew, since that's the language of instruction at the Technion. So basically you see me standing in front of the class, presenting a clicker question to the students. This is a lesson on plant economics. Why is the approximate probability analysis method approximate? What are the reasons for that being an approximate method, with various options being offered to the students? Give them time to answer. Got a class size here of 54, which is about two-thirds of the class. This is typical. So the answers are collated, and we see here.
Because at home you were 70% right. Okay.
All right. So typical activity, getting an idea of if students have actually learned something incrementally from the observation of the lectures at home and as a result of what we discussed in the class meeting. What happens in the 3-hour active tutorials? Well, the main purpose of these sessions is to allow time for students to solve classwork exercises for themselves or working in teams. The course staff are there to facilitate and not a source of solutions. Thus, most of the time is spent by students working the problems for themselves. Solutions are not submitted, sample solutions are posted after the tutorial. And what's really, really important is to notice that these sessions, the active tutorials, are actually where the main learning takes place. This video shows what a typical active tutorial session looks like. A lot of noise. So we see here the students working in groups, sitting around tables, working problems. The assistant is there to prompt, to trigger a discussion, to get them thinking. But basically the work is being done by the students. And of course the lecturer is there also to get feedback for himself and to see really how much the students know. Very intensive activity. And of course students tutor each other. That's also fine too. Again, this is where the real learning takes place in my course. And the more time we allow for this, the better it is. The neat thing about the flipping approach is that it's given us much more time to invest in the active tutorials, and we're seeing even better results as a consequence. Okay. So, does the approach actually make a difference? Objective evidence would be the performance of the class as quantified by the final exam grade distribution. So let's see some data. Here again is the distribution of the final grades from the 2008, before I made the switch to active learning. A depressing failure rate of 15 out of 84 students, with close to 50% of the class attaining mediocre results or worse. And here is the distribution of the final grades from 2015, the first attempt at flipping the class in this course, in which all of the contact time with my students engaged them actively. The failure rate is now down to 7 out of 85 students, and more impressively, those that pass the course pass very well indeed. So it's fair to claim that the flipped approach leads to better class-wide outcomes. But what do the students think? This being the first instance of a 100% flipped course at the Technion, we poll the students 3 times during the course: in the first week of class, at midterm, and at the end of the course. In this slide we see the distribution of responses to the question, is the conventional approach the best way to teach this course? At the start of the course, the opinions were evenly split between those who agreed, disagreed, and were non-committal with the statement. By the end of the semester, only 12% of the class still thought the conventional approach was best, with over half the class convinced it was not. This would suggest that the students might be enthusiastic about the flipped alternative, right? In this slide, we see the distribution of responses to the question, is the flipped approach the best way to teach this course? By midterm, over half the class had already decided that it most definitely is, with about a quarter of the class adamant that it was not. By the end of the course, those in favor of flipping had increased to about 2/3 of the class, with the same die-hard opposition from about a quarter of the class. Interesting that almost no students were left undecided by the end of the semester. You either love flipping or you hate it. Even more interesting is that of the 28% who didn't like flipping, half of them admitted that they learnt far more effectively with a flipped approach. Indeed, analysis for the reasons for the opposition to flipping is their impression that it involves more work. However, adding up the time allocated for each of the 2 approaches shows that in fact flipping does not require more time. The same amount of time is just used more effectively with the flipping approach. Even so, about 50% of those who didn't approve of flipping nonetheless agree that it makes their learning more effective. I recommend that you try flipping your classroom too. Here's a tip to get started. The preparation of the online video lecture segments and quizzes is quite a load on the lecturer. For my 100% flip design course, I recorded over 100 video clips and generated over 100 quiz questions. This is a huge load, but note that it is a one-time investment. If you get started with just one lecture rather than going 100% flip the first time, you will get a taste of what the approach can do for you whilst making only modest initial investments. Don't get discouraged if your first attempt is not as a resounding a success as you hoped for. Remember that flipping is new to your students too, and it's easier for them to stay passive, so expect some opposition from the diehards. As a candidate for your first flip week, pick the lecture that you never managed to fully cover in a regular lecture slot, and make sure that you include the class meeting and active tutorials too. Both of these are key elements. I am sure the result you obtain from such an experiment will encourage you to flip more classes, just as it was for me.